Okay, so I wanted to take just a minute to go through some number conversion examples for you. Let's begin by taking the number, the decimal number 25. Okay, and let's convert this to binary. So when we're converting to binary, we're really doing the same operation over and over again. All we're doing is we're taking this number and we're dividing by 2. Okay? Now, when you divide by 2, there are effectively two possible outcomes. Either a number will evenly divide by 2, because all even numbers divide by 2 evenly, or a number will have a remainder of 1, because all odd numbers have a remainder of 1 when you divide by 2. Well, this is an odd number. So what I want to do is I want to take the whole number part of the the whole number part of the division, 12, and keep note of the fact that that is 12 with a remainder of 1. So 25 divided by 2 is 12 with a remainder of 1. All right, let's divide 12. All right, this is 6 with a remainder of 0. Okay, let's divide by 2. This is 3 with a remainder of 0. Getting a little ahead of myself there. Let's divide by 2 again. That's 1 with a remainder of 1. And let's divide by 2 again. And that's 0 with a remainder of 1. And if we divide by 2 enough in this fashion, we will always eventually get to 0. Now, take a look at this number right here, okay, that I'm putting in this circle. That looks an awful lot like binary. And in fact, if we read it from bottom to top, we get the binary number 11001. Okay, 11001. And in fact, 11001 is the binary representation of 25. Okay, let's prove that. So we're going to go the other way now. We're going to go from a binary representation to a decimal number. Well, we know this is the 2 to the 0th place, and you know that because you've already read the chapter in the Xi book. Okay, this is the 2 to the 1 place. This is the 2 squared place. This is 2 to the 3rd. And this is 2 finally to the 4th. Okay, so that's 1. That's 2's place. This is the 4's place. This is the 8's place. And this is the 16th place. So we've got 1 times 16 is 16, plus 1 times 8 is 8, plus 0 times 4 is 0, plus 0 times 2 is 0, plus 1 times 1 is 1. And if you add 16 plus 8 plus 1, you get 25. Okay? All right, let's do something with conversions from binary to hex. All right, so here's a binary number. I just randomly selected these digits. Okay, 1101, 0011. All right, and I'll tell you that in decimal, this is the number 211. You can figure that out. Check that out for yourself. You can do it. All right. So when we are taking binary and we're converting to hexadecimal, we take the numbers 4 digits at a time. Now, not accidentally, this is an 8-bit binary number. Okay, because it nicely converts into hexadecimal. But even if you don't have exactly a multiple of 4 numbers in your binary number, you can just add zeros to the front as you need them. Okay, because just like putting zeros in the front of a decimal number, it doesn't change the number. It just adds meaningless numbers at the front. Okay, but we're going to take these and we're going to look at them 4 bits at a time. Sometimes we call these the high bits and we call these the low bits. But we're going to look at them 4 bits at a time. And the reason why we're going to look at them 4 bits at a time is because consider this. The lowest possible 4-bit binary number is 0. Okay? The highest possible binary bit number is 16. Okay? So, 15. Right? So, keep in mind that the numbers 0 through 9, and then so that's 0 through 9, 10, 11, 12, 13, 14, 15. A total of 16 values, 0 through 15. 0 through 15. These are the hexadecimal, these are the hex numbers, right? That you'll recognize from your reading in the book. Okay? So the possible values here are between 0 and F, and the possible values here are between 0 and F. So every 4 binary digits, every 4 bits, is going to represent a single hex digit. Okay? So 1101, I will tell you, is 13 in decimal. And you can check that for yourself. It's 8 plus 4 plus 1. And 0011, well, that's 3 in decimal. That's 2 plus 1. Okay? The 13th, 0 through 9, 10, 11, 12, 13 is D. And 3 is the third number. Okay, 0, 3. So, D3 is the hexadecimal version of this binary number and this decimal number. Okay, so D3 is 211 and D3 is 11010011. Okay? All right, let's go the other way. Let's start with a hexadecimal number. Let's say 3F, for instance. Okay? How do we go to binary? Well, we know this is going to be 4 digits. Okay? And 3, we've already seen, is 0, 0, 1, 1. Okay? Now really, we can ignore the leading zeros here. And F is 1, 1, 1, 1. Okay? All right, so that is the decimal version of this number, this hexadecimal number. So I leave it to you to figure out what that is in decimal, just to check that you understand what we're doing here. Okay, I hope that helps. Let me know if you have questions as you're working through your lab, and I will be talking to you soon.